Good morning, kids. Today we're going to look at a few of these fancy division equations here. Looks pretty hard, doesn't it? It's really not. You just have to look at this a little bit differently than what we've been looking at, okay? This is 6,099 divided by 19. And we're not used to dividing by a two-digit divisor, right? The dividend, the divisor, 19. 19 is one number, okay? Just like 7 is one number. You've been dividing by 7. 6, 5. 19 is just one number. Think of it as one number, not two numbers. It's not two numbers. It's two digits, but not two numbers. Okay. Now, we've done this a little bit last week. So the first thing I'm going to ask you to do is I want you to work this. Now, pause the video, work this, and then come back and we'll check it. Go. Okay, now we're back. Hopefully you work that. We're going to work several examples today. We're not going to give you any homework today. We're just going to work a few examples. The classwork that we do will be mainly on Google Meet today. So if you're not on Google Meet, this is what you would need to look at, especially this. All right. The first thing, again, we're looking at is one number. How many times does 19 go into 6? If you're skip counting by this number, how many 19s can you fit in 6? Of course, the answer is none, 0. So I like to put a 0 on the top as a placeholder because if you forget about this place being filled and all your digits are sliding over one place, the answer is always going to be wrong. So keep this, especially with decimals. Okay, so how many 19s now go into these two combined, these two digits? 60. Now, I know you didn't memorize your 19s, but think about this for a second. Estimate. You always estimate. This is about what? Yeah, it's about 20. And it's easy to figure out how many 20s go into 60. 20, 40, 60. It's 3. So you can do that in your head. A lot of this you can do in your head. Don't let it intimidate you, okay? 19s into 60 go 3 times. Again, that's our division. Multiply next. 3 times 19. And if you go, I don't know what 3 times 19 is. Guys, all you have to do is multiply on the side if you need to. 19 times 3. And here we go. 9 times 3 is 27. We did this a few weeks ago. This would have been the easiest problem we did 3 weeks ago. 3 times 1 is 3, plus 2 is 5. So 3 times 19 is 57. The next step is subtract. 60 minus 57 is 3. I just know that by counting up. Now you can regroup and do that. 10 minus 7 is 3. 5 minus 5 is nothing. Either way. Okay, now the next step, bring down. Just like we've been doing for the last week or so. Now, how many 19s? Again, that's about 20. Go into 39, which is about what? 40. So how many 20s are in 40? 2. And again, if you don't know what 19 times 2 is, just work it on the side. Now, this is actually 38. We divided, we multiplied, now we subtract. And we get 1. Now, the next step is bring down. As long as we can bring down, we're never finished. Oh, now this is easy. How many 19s go into 19? 1. And 1 times 19 is 19. No remainder. Nothing to bring down, so we are finished. Put our remainder up here. And we can clean up our answer, get rid of any unnecessary placeholders. And that is our quotient, 321 with a remainder of 0. Is that what you got? If you did, thumbs up. If it's not, but you learned something from this, thumbs up. Either way is good. Let's try another one. Let's try this one. We will do 7,249 divided by 21. Divided by 21. And again, this time I want you to work this, pause the camera, work this, and then come back and let's check. Go. Okay, now that you're back, let's check and see what you did. Again, this is one number, 21. Don't let that scare you just because it's 2 digits. It's one number, okay? This is about 20 again, a little bit more than 20, but it's still about 20. This is about what? 70. So how many 20s go into 70? Just skip count. You can do this in your head. 20, 40, 60. 4 20s is 80. That's probably going to be too much here. So it would be what? 3. See how you can do that in your head? Oh, you know what? Let's not get ahead of ourselves. We can get so good at this that we forget a step. It's actually how many 21s go into 7. Yeah. When you learn this really well, sometimes you skip right on through that and don't think about it. How many 21s into 72? 3. All right. We divided. Now we multiply. 3 times 21. Again, if you don't know it, do it on the side. Really, that's mental math, folks. 3 times 21 is 63. And then we subtract. 2 minus 3, we cannot do that. So we regroup. 12 minus 3 is 9. 6 minus 6 is nothing. 0. We just leave it blank. And we have subtracted, and we're going to bring down. Now, once again, ask ourselves, this is about 20. This is about what? 90. So let's count up to 90 by 20s. 20, 40, 60, 80. That would be 100. 5 would be 100. So we've got 4 that make 80, right? So 4. See how much easier this is? Now, we're not going to put 80 down here. We're going to actually multiply it out, but we know it's going to be around 80. So 21 times 4 is, of course, 84. So 4 times 24 is 84 with a remainder of 10. And we cannot stop because we still can bring down. Right? And then one more time. This is about 20. This is a little over 100. So let's think how many 20s go into 100. 20, 40, 60, 80, 100. I'm thinking 5. Let's try 5. And again, you can, on the side, work 21 times 5, if nothing else. 5, 10, we find out that's 105. So 5 times 21 is 105 with a remainder of 4. We cannot bring down, so we are finished. Our remainder is 4. Put our remainder up on top. Clean up our answer of any unnecessary placeholders. And our quotient is 345 with a remainder of 4. It's that simple. Okay, let's work one more. One more real quickly. All right. How about this one? All right. Let's see if you can work that. Again, work it. But before you do that, pause this and then come back. Okay, now that you're back, let's check. This is a little bit more difficult because when you estimate this, it's sort of between 10 and 20, closer to 20, but still a pretty good distance from 20. This is in the middle of between 60 and 70. So I like to estimate high, usually. So I'm going to estimate that to 20 and that to 70. And let's check, right? 20, 40, 60, that's too much. That's 80. So I'll say 3 times. 3 of these, okay? Multiply by 3. Again, we skip the first step just because we know that so well. We just go right on past it. Because 16 does not go into 6. 16 into 65 is, what did we say? 3 times? And 3 times 16 on the side is 48. We need to regroup, don't we? So let's regroup. And we get 17. We have a problem here. The problem is this, and keep this in mind. Whenever you subtract your remainder down here, this is not the final remainder, but your remainder so far cannot be 16 or more than 16. This is more than 16. We have a problem. We just found out 3 is not large enough. We can go 4 times. Now, that's not a mistake that we made because we estimated. And we knew it may or may not be true when we estimate, but we'll be close all the time. This time we were close, but we need to correct it. So we'll make it, instead of 3, 16 will go 4 times. There's one more 4, or one more 16. So when we work that out, we find out that 16 times 4 is 64. We're right next to 65. Okay? So we'll take this out. And sometimes you'll need to do this. Sometimes you'll estimate and not quite get there. And that's fine. But you'll always get close. Always close. And then bring down your 3. See that? Now, watch this. How many 16s go into 13? You're right. None. 0. 0 is a number, so we'll put it on top. And we need to multiply by 0. 0 times 16 is 0. And you talk about some easy subtraction, right? 13. Bring down the 8. And since this is the last digit to bring down, this last turn around, this last rotation through our steps will be finished. Now, this is about 20. This is about 140. So, how many 20s, if you skip count, go into 140? 20, 40, 60, 80, 100, 110, or excuse me, 120, 140. I'm counting 7. Let's try 7. 16 times 7. And again, we're estimating, so we may or may not be correct the first time, but we'll always be close. If we don't get it right the first time, our second guess is almost always going to be right because we're right next to the number we need. 7 times 6 is 42. And 7 times 1 is 7 plus 4 is 12. 112. You know, that looks a little small to me. If I put 112 down here, I'm going to have a remainder of 26. So that is too small. So if 7 is slightly too small, what would be next? Yeah, 8. I'm sure 8 will be it. So let's try 16 times 8. Again, this is not hard at all. You just have to stay with it. 6 times 8 is 48. And 8 times 1 is 8. Plus 4 is 12. 128. And that's fairly close. So we're going to go 8 times 16 is 128. The remainder of 10. There's nothing to bring down. 10 is smaller than our divisor. So 10 is acceptable as a remainder. Remember, your remainder must always be less than the divisor. Cannot be equal to it. Certainly cannot be larger than it. It must be smaller than 16. Smaller than your divisor. If your divisor is 48, the remainder cannot be 48 or more. It has to be 47 or less. Right? Sometimes you can have gigantic remainders, but only when you have a gigantic divisor. That's how it works. Okay, we have a remainder of 10. We put that up on top. And again, what's our last step? Clean up. Clean up our quotient. Get rid of any unnecessary placeholders. And our final quotient is 408 with a remainder of 2 or 10. 408 with a remainder of 10. Did you get that? Good. Good. Okay, that's our practice for today. I do not have any other assignment for you, but I want you to go through and just make sure you understand those steps because tomorrow will involve this type work. And you should be ready to really do something that's gradable, okay? So I can give you some good credit for the good work you do. Good job. Have a good rest of the day.